Okay, so what we were doing, we were cloning our repository. So if someone could copy that link into the old YouTube link, so that if anyone's just on the old YouTube link, they can see to move across to the new one, that would be great. Yeah, so we've cloned our repository into GitHub. Now, if anyone into a folder called GitHub. Now, if I've missed some of that by the interruption, let me know and I'll go back over it. But basically, it was in git bash. We just ran these 4 commands, and I'm about to do the last one. Well, actually, in fact, I'll do that later. Okay, now we're going to create a virtual environment. So, and we'll do that while we're here. So in Windows, it's Python -module VNV, use the virtual environment module. And we're going to create one. Let's call it Beginners Python and Machine Learning 110. Okay, and then we need to activate that virtual environment. So I've given you instructions on Mac or Linux. You probably want to use Python 3. On Windows, Python is just Python 3, so that's fine. And then you have to type source and the name of the virtual environment and where to activate it from. On Windows, you don't need the source word. You just type activate. So it's BPA scripts activate, and we'll do activate dot bat. And I'm not getting anything here, but that's because I'm in git bash. So let's try that in the command prompt. So we'll run our command prompt. So Python does work in git bash, but it's a little bit, some of the output is not great. So it may be working, but we're not seeing anything. All right, so from here, we'll change into GitHub directory and we'll activate our virtual environment. That's right. You can see the virtual environment is activated because the name of the virtual environment starts at the beginning of the prompt here in parentheses. And we're going to install one third-party library, which is XLSX Writer, which is for creating Excel files. So once we've activated, we can install it. Now, normally I'd get you to write a requirements.txt file and put this into the requirements.txt file and then install from there. Because there's only one, we'll just do it a little bit differently tonight. All right, so let's check it's working. Now, to check it works, we're going to need to have 2 command prompts going. So I'll open another one. I'll right click on here and click command prompt and bring it over onto this window, this screen. I'll put it on the left hand side using Windows left arrow. We'll get into the same directory. We'll activate the virtual environment here as well. So it's BPAML scripts activate. Okay. Then we'll change into our Git repository, into the online sessions, And if you have a look in there, and I don't remember which shell I'm in, dir, where there's the one we want to use, meetup 110, and that'll be available to both. So let's change directory on this one as well. As I'm using tab completion to make it a bit easier, so I type the first couple of letters, then press tab, and it fills it out for me. Okay, so if you're I won't change directories quite yet. If I do a dir on this directory, you should see a folder here called bpaml110. So Howard's not finding that, and if you're not finding that, then you may not have run the command, which is creating the virtual environment. So the command is python -module virtual environment bpaml110. Okay, so that'll create the virtual environment, and then the next command will activate it. So you have to spell it the same way in both times. See if that helps you find the path. Okay. So now I'm going to change directory into the session summaries. And if we look in session summaries, we can see that there's an online folder. So I'll change directory into that. So now it's going to be easy to run this Python script because it's in the current directory for both. Now if we look at the next thing that we have to do, we have to run both the server and the client. Now I guess I made a mistake here, I put client first, but you really want to start your server first and then start your client. And what we're really trying to do is run a little client server setup very similar to what they've done on the real Python site. Okay, so lnaz is written or cd ... So cd ... will take you up a directory if you're down in the directories. So it looks like to me Howard's in the right directory, but yeah, anyway, let's see how he goes with that. So let's have a look at this web page. So this is all about socket programming, and it's quite a good tutorial here on how it all works. And it explains how we do network connections, and that that's the API of the functions that we have to use. And this is really what it looks like. So you can see the server has to start first. It creates a socket. It binds that socket to a port. So the port is just a number, and only one program on your computer can be bound to any port at a time, because your computer is can have these connections coming to it, and each connection says which port it wants to bind to, which port it wants to connect to. So the computer will work out which application has bound to that port and send the traffic to it. So we're going to be binding on port 9100, and then we'll just be listening there until something happens. Now then the client program starts up, and it creates a socket, and it sends the connect across to here where the server is waiting to accept a connection. And once it's established that connection, then the server can start to receive data from the client, and they send data back to the client. So how this happens, all these sending and receiving of information, that's your protocol that you have to set up between your devices. And just make sure that they're both expecting to be sending data and receiving data at the right times, and you can send messages between them to tell them to do different things. And at the end, the client sends a close message. When it receives that, it can close the connection, And you can have several clients running at different places and all connecting in to the server, and you just have to set up your code so it can accept those multiple connections. So what we're going to do today is we're setting a virtual printer. That will be a server just sitting waiting for stuff to come to it as though it's been printed to it, and then that will be it will work on what data it gets, and then at the end we can close it and it'll save an Excel spreadsheet for us. Alright, so let's see if we can get a little bit going. They've put some code here in Echo Server. So basically the server receives data and it just sends straight back the data that it receives. So that's what the server looks like. You can see it's doing the things, it's doing the bind, it's doing the listen, it's doing the accept. And then with that connection, it will do the receiving and the sending. And it just says while true, so that's an infinite loop. But we've got a break statement in here that'll get us out of the loop. And this with connection is with is a Python keyword, and it's used in a lot of places, so that once the program gets out of the with, it automatically closes any resources that were required with that. So you can use with things like opening files and reading the contents of a file. Here it's used twice, once with the socket and once with the connection, because you can have one socket and then multiple connections within that socket. In this case we're just doing one socket, one connection. Alright, so I've got no questions on that so far, so let's give it a go. So to run a Python script, we type the Python command to start with. In fact, well, let's just check that Python's working. So you can type Python -- version, and it should give you your version number of Python. Now, if your Python isn't working here, well, then you wouldn't have been able to create the virtual environment in the first place. But I should just help people who are stuck in that situation that they can't install a virtual environment. If Python doesn't start here, then it means that you haven't got the right environment variables. So there's an environment variable called path, and you can see what that is. And it doesn't get set up by default when you're installing Python, so you have to tick an extra box to make it available from the command line. And it puts in here, it says where the Python is getting installed. So mine is installed in users Python, app data, local programs, Python 39, and then there's two things there, there's scripts. So how do you edit that if you forgot to tick the checkbox when you were installing Python and you didn't do that? So you can go to the start menu and type environment, and there you can edit the system environment variables or the environment variables for your account. So let's do the ones for our account. And that brings up what they are, and it's this path is the one that we want to look at. So if we edit that, that shows us what's on our path. And you can see there you need to add Python 3.9 scripts and Python 3.9. So those two have to be there. These ones are for other programs, and so you might have them or you might not. Now if you need to add them in, you can just say browse where you want to go. So it could be you've installed it in program files, in which case find it in program files. In my case it was in app data, local, programs, Python 3.9, and so you'll want that folder there and say OK, and then you'll want to do the whole thing again and find the scripts folder and say OK. So let's see if we do that folder and say OK. You can see it adds it onto the list here, so that was a bit easier than typing it in. But I don't need it twice in there, so I'll just delete this one. So yeah, Leo asked why the scripts as well. I'm just saying that because they were there. I didn't put them in there, so the Python installer has decided that you needed the scripts. So that might be things. Let's have a look what's in those folders. programs, Python 3.9. Yeah, so pip is in the script. So if you want to be able to do your pip install, then you need to have that in your path as well. If you don't have that in your path, you could do Python-m pip install, and that's how you run the pip module without having the scripts folder in your path. Okay, so now we can type Python and it'll recognize it, and we'll put in the name of the script that we want to run. So that's going to meet up 110, and I'll just get to 11 and then I know it's unique. And then we're going to do some command line arguments after it. And there I'm going to set the mode, -- mode, and I'm going to do the server. So it's all caps server, and run. So now it's running as a network socket server, bound to port 9100 successfully. No other app is using this port, so that's good, and it's listening on that port. Now in another terminal window, let's run it at the same script, but run it as a client. Okay, so the client received this data, it sent this data here, hello, and then some Unicode, and that, and then the server sent it back in the reverse order, and so the client got it. So they're the bytes that it got, and that decodes back into Unicode of ? Hello, spelled backwards. And so you can see that's what it sent, that's what it got back. Now, when I first set up these scripts, I thought I'd do something to show you the difference between bytes and characters in a string, and so Unicode is a really good example of that, because Unicode can have multiple bytes for a single character. And so I thought, well, I'll choose the Australian flag. There's an emoji, a Unicode character for the Australian flag. So I went to a website and copied that into my code. So where did I get it from? I got it from this website. And it lists a few of them, and it also explains how they work. Now when I pasted it in on my Mac, this is what it looked like. Hello, an Australian flag. So I thought that's great, but you have to send bytes, so it encodes it into UTF-8. Now Elnaz has asked a question. s.sendall.encode is in the client part. I'll just bring this over so everyone can see it. Yes, so the server is listening. The server just waits, and it's the client who actually connects to the server and tells it what to do. So the server is sitting there waiting, not doing anything. The client sends data, and it sends hello flag to the server, and then the server does something with that data, and our server is just a simple server. All it does is reverse the characters and sends it back. So we can see here on in Slack is displaying this code as an Australian flag, so that's brilliant. In our Google here on Windows, it's displaying it like that. Hello HM, and there's a funny HM, so they're different Unicode characters. And in fact, I tried a few Windows programs trying to actually display that, and I couldn't find any, but Elnaz has found Slack actually works, so that's great. So the client sends that data, the server rearranges it, and then sends it back. So in our code here, we had the server running on the left. It reported that it received this code. That's what it received from the client, so it reported that. And it decoded it into Unicode, probably correctly, just couldn't display it. And then it reversed it and sent it back. And then the client said, I got it back in the reverse order, so I know that you've sent it correctly. So that's what's happened here. And once the client's then gone one message back, it goes, that's all I wanted to do. It disconnects, and in our server we said only receive one message and then you can disconnect as well. So it's closed itself by jumping out of the with connection block, and the whole program script finished. So does that make sense? So yeah, does server side send it or client side? So the client sends it first, the server receives it, processes it, and sends something back. And that's just, if you look at this diagram here, you can see the client sends, the server receives, then the server can do something. You can go down and send something over to here, and this client receives, and you can either go back up here or it can say I only wanted to do one thing. And similarly here it can go back and receive some more, or it can continue on. Okay. So that's we've written our first little server and client network program. And there's not a lot of code required to do it. Nothing really interesting there. The 1024 is the number of bytes it will receive at a time, but we only sent a few bytes, so we didn't get close to that. Now what was interesting was those flags. I expected to see an Australian flag and then OLLEH, but the Australian flag is not actually a single Unicode character. It's actually, so I thought it was a single 8-byte Unicode character, but it's in fact 2 4-byte Unicode characters. So when we reversed the characters, those 2 4-byte characters got reversed, and the data that came back is actually a different flag when it displays as a flag. So anyway, that's a good example for getting your head around what the difference between characters and bytes are. And I didn't even know that there existed these 2-byte characters, 2 character symbols in Unicode. So I hadn't seen that before, and so I learned something new by doing this exercise. Okay, what's next? Yeah, 1024 is 1 kilobyte, and you'll often see it written KIB now, and so K without the... Oh, good, Elnaz has sent back the flag that she got in return, and you can see it is a different flag. So I'll just put that on the video. Yeah, so KB is often 1,000 bytes, and KIB is 1024 bytes, and so that's 2 to the 10th. So that's often why you see people using that number, 1024 rather than 1,000. Okay. All right, so the next bit, we're going to create a generic text-only printer. So here's some instructions in Windows on how to do it, and some instructions in Mac. So let's give this a go. In Windows, we'll go into Settings, and Devices, and Printers. And I've already got one that I've created, but I'll create another one with a different name. So we click Add Printer, and we wait for a little message to come up, my printer isn't listed, and we'll click on that. And that'll bring up a new window, which has gone on to my other screen. And from that, we'll add a printer using a TCP IP address or hostname. And we're going to make it a TCP IP device. And the name's going to be 127.0.0.1. And the port 9, because I've already got one, it's put an extra -1 under that, _1. Query the printer, and automatic. I'll turn that off. Detecting the TCP IP port. So Windows, what we're doing here is we're setting up a printer that will send something to that particular port. So it's not listening on the port, it's going to send it to the port. So we're going to send data to this printer, and then the printer is going to look for our virtual printer to actually give it the data. Just like it was a physical printer, it would give the data to it over, say, a network or a USB cable. And this is taking a fair bit of time. Meanwhile, if you're on a Mac, you might have to go into the command line and type this command, cups control web interface equals yes, and then you can browse in a web browser with either of these links to start bringing it up. Okay, let's continue on. Device type, generic network card, that's correct. And so we want generic text only. And next, use the currently installed driver, and it should be currently installed by default. And then we'll give it a name. So this is where you'd say, print to xlsx. I'll call it print to bpaml. That'll do. And we want to share the printer, and we've given it a name. So that'll do. All right, it's asking to print a test page. All right, so while we've got that up, let's run our Python file, and this time we'll do it in mode as server receive. So the first one was a server echo. We were echoing back the data in reverse order. This time we just want to receive it. We don't want to do anything. We don't want to send anything back because this printer here is not expecting any data to come back. So let's run this. Server receive. Okay, so now we've got our virtual printer running on the socket, network socket server running on port 9100. And now if I click print a test page, because it's just a text-only printer, it's sent data as text out to our program, and so our program's received all this data across the network, and it's printed. And you can see I've printed line numbers as the data's come in, and up to this point it's printed the first slot, and that's the first 1024 bytes, and then it's continued on with the next slot, and then that's stopped because there was only one file, and we've said in server receive that we only want to receive one connection, and then we're going to quit the program. All right, how did people go? Did anyone manage to get a test page to get received in their virtual printer? So finish that. Is there anything that you want me to go over again? While I'm waiting for that, I will run through what you have to do if you're on a Mac. So let's go to here. So if we're on a Mac, we run the cups interface. So let's, here we go, I've got that, I've connected to that. So let's move this to a new window. So, and we've got, you go to the administration, and at this point you might need to type in your super user password. Okay, so LNAS doesn't have any printer to set up. You don't need, what we're doing, our Python program is the printer that we're setting up. So that's why we can go to this, you click add printer or scanner, and even if you've got nothing here and you've got no printers connected to your computer, you can still click on that and it'll search for it, but of course you don't have anything there. So then you can click on this, the printer that I want isn't listed. And so you click on that, and that's where you'll get this window coming up. And you're going to say add a printer using a TCP IP address or hostname, because that's how you're going to talk to your Python printer. So we're writing the printer as a virtual printer, and you should be able to continue on doing that. So does that make sense? I'll leave that just down there. And when you finish setting it up, it'll appear in this list. So I've got one here, print-to-xlsx. So that's our virtual printer that we've created. And on Mac, we go here, add printer. And we're going to use HP Jet Direct. So HP Jet Direct is the protocol that uses port 9100. So, and that's what the generic text-only printer used by default on Windows. So we'll use the same one on Mac. Okay, so there's our protocol. So the program's going to be running on the same computer, and it's going to be listening to port 9100. In fact, let's see if we can have the Mac send the data back to our Windows printer. So if you're doing this all on the same computer, use that IP address 127.0.0.1. And I'm going to, for my testing, because I'm just going to be running the Python program on my Windows computer, and it's going to have that IP address. And I'll call that print-to-xlsx. That'll do, and I don't have to share it. So this is what the instruction I'm following. Add printer, socket, print-to-xlsx, don't need to share. Continue. Raw. Continue. Raw queue. Add printer. All right, I'm going to cancel this one here unless anyone else needs me to go through that again. Okay, print one Python file to printer and see if it saves it. So that worked. So let's have a look. Yep. I'm going to run my server again. And then I'll do this. I'll try running this from my Mac. So I just have to connect to my Mac. And then I'll go into GitHub, session summaries, and online. Yep, the file's there. But in fact, I didn't need to do that one. I could do anyone. I could do Meetup 109, for example. And I just need to... In fact, the Python is running here on Windows, so all I'm doing over here is printing. So let's find the print command. It's just LP and then -D for destination, the name of the printer and the file I'm going to print. So it's LP-D, and I want to print-to-xlsx, and the name of the file. So on Mac, most of the print commands from applications actually produce a picture of a PDF document, or PDF document as a picture, so it doesn't work with our text-only printers. But printing from the command line does work, so that's what I'm doing here. Okay, so remember we've got our server running here on the left, and let's see what happens when I print on the right. So that's printed. This is listening on port 9100, and it didn't receive anything, and I didn't get any error messages. But that could be a Windows networking thing, that Windows networking has blocked port 9100 coming from outside. So I can't see any messages coming from Windows. No, anyway, that should have worked. It worked when I tried it on Linux. It doesn't work here when I've tried it on Windows. But I could run a server here on Mac and send it locally, and then that would work as there. So if anyone wants me to spend more time on the Mac side, just let me know and I can get that working. But firewalls will block your printing. So if you've got port 9100 blocked, your printing won't get through. Okay. Okay, so what we want to do now is run a command line script to print all the Python scripts in the online directory. And so to do that, we're going to use these DOS commands for files that match ending in .py. So I'm not going to do the Python notebooks, just the Python scripts. So /m for match, *.py/c for run this command, and the command is going to be cmd/c print to my computer print-to-xlsx, the name of the printer, and then @path. And meanwhile, my printer is going to be running as a server, an Excel server. So it will be able to process all those files as they come in. So this one is going to get many connections. Every single file is going to get printed. And what we're planning to do is extract our YouTube URLs out of the file and put them all into a spreadsheet. So let's see if that works. Okay, this one here didn't work, so I'm just going to Control-C to stop it. And Control-C didn't stop it. So let's just close the window. So that's usually a sign of something to do with the firewall. So I'll activate my That's the name of it. Activate. That's it. And then I'll run my server. Now I don't need to change into that directory to do this, so I can just do it from here, but I have to fully qualify the file name. And then the mode is my command line argument, is going to be server-xlsx. So that's waiting for a connection. And then we'll get our command from here, which will for all the files. No, I don't remember which. So paste is just Control V. I should have known that. Let's try again. Control V. Control C. Control V. Should I say Control V? Copy. Paste. All right, let's just type it. /m. Oh, in fact, I've got to get the right computer name as well. And my computer name is, I think I know it. It's desktop AV68, something like that. So we can get that out of settings. NVO, AV68 NVO. Well, there you go. I thought I tested this, but obviously I haven't. Let's try PowerShell. There we go. So it works in PowerShell. and our printer here didn't do much. And meanwhile over here, let's get our virtual environment working again. Ah, there we go. That's why it's not working, because I'm on the Mac, and the virtual environment's still running over here. So what I want to do now is run the Python. Now I've got to tell the server to save the Excel file. So I've got another mode just for that, which is called save xlsx, telling printer to save xlsx file. So this one here should have stopped. Okay, so we're not getting a lot of success here, and the fact that Control C worked. So we've got a log file we can look at. Yep, we got that. Let's have a look at the spreadsheet that got produced, and it's empty. Yep, so the printing of all the files didn't come through, but that's all right, because we can do that again. So it looks like everything's working there. And let's now that we're over here, there we go, that printed fine. We'll go into settings and have a look at our printer queue. Yeah, so we've got something happening in the queue. So these are all the things that have been tried to print to our virtual printer. So let's just clear all of them. And we'll try running there we go. So that's we ran the mode to save the Excel file. Something might have happened that time, so let's give it a look. Still nothing in there. And we'll have a look at the log file. It's just got the last bit. So we'll just try printing one document and see if because we're getting the save xlsx is working. Okay, Onez thinks there's a bug in server xlsx, but if you do find a bug, let me know. So the print command /d : okay, and I'll press into there. So that printed it, but we're not getting something there. So I'm thinking there's something more likely happening with our printer. Yes, he's got one in the queue. And it could be that I've got two printers going to the same place because I created that extra printer. So let's try printing to this one, print to BPA ML. There we go. So that worked. So it's because I've created this new printer, the other printer is not working. And you would really only just have that problem because you've you would only have one printer set up. All right, so that worked. So let's do server xlsx, and this time on the left. So there's our server running, and then over here we're going to do all our files, but we're going to send them to the new printer I created tonight. And there we go. So it's processing them all on the left. As each one comes through, it's creating a different log file for each one. And then we'll run the command to say save that Excel file that we've created. And so it saved it. And now let's look in our folder. And there's our links. And here we go. We've got every meetup that I've done in the online session, and we've got the YouTube URL in column B. We've got any Google Colab URLs in column C, and we've got any meetup URLs in column D. All right, so Elnaz has got an error. All right, let's have a look at line 97. All right, I'm going to open this in Pycharm so I can get some line numbers. So I'll show you how to set up a new project in Pycharm. So let's call it Meetup 110. Now let's use a previously configured interpreter. And we'll find the one that we've created. Here. It doesn't have to be available to all projects. And we don't need that. Okay, so it's created a project for us, and we'll save our file from here. Save page as. Okay, don't need to worry about that. Line 97. My line numbers don't match up with yours. So what we're looking for, if not in first. Okay, so if you've got a an error in this line, that's because I've used a Python 3.8 code. This is called the Walrus Operator. So if you're running Python 3.7 or earlier, then you'll have to change this. And what you'd change it to, well, you could just on the previous line, you just put m equals pattern docstring dot match. So pattern docstring is a regular expression, and then on this line, you just need m to say there's a map. So if the word docstring's not in this dictionary as a key, and so that just means we've already got it. This finds the first docstring, the first title, the first YouTube URL. So if it hasn't found the first one, then we can still put one in there, and we set it to the first group from this. So we're matching a string that's got either starts with an F or an R. It's got 0 or 2, 0 to 2 characters there, and then it's got either single quotes or double quotes, and it's got 3 of them. Then it's got what the docstring actually is, and then we don't need anything on the end of the line. So it just grabs whatever that is, that first line, and puts that into the title. So let's have a look what we've got here. So that's really looking like you're missing. You're not running Python 3.9. So I'm not sure what IDE you're using, but if you're using Pycharm, just go down into Terminal, which I've got as PowerShell, and type Python version 3.9.5, or go into Python console, and when it'll start up, and it should tell you, and it hasn't. Sys dot version 3.9.5. So that's how you can check. Alright, and I've got a thing here about this. Alright, any other questions? Good. Elnaz has solved that. Now, did you find this interesting tonight, what we've done? We haven't really looked too closely at the code, but if people are interested in that, I can do that in future sessions. I think it's it's a real-world example of where you might use Python. You've got all these files, and you want to grab some information out of each one. And otherwise, a novel way of doing it is using the print functionality to get that data out. So Leo said he was coding along. Oh, that's good for Leo, because he normally doesn't. He normally just watches. Great, thanks, Elnaz. You like that? That was good. Okay, there were a few hiccups in the video tonight, but hopefully you picked something up from the debugging that I was doing. And just the way that you can debug these things. Next week we'll be getting more onto machine learning, so Arun's going to take next week's session, and I'll be taking the next one the first week in September. I'll do that, and then maybe one more session during September. I'll probably go through the code that we've done tonight. Okay, so Leo watched the first part twice because it was confusing. So was it what I was presenting that confusing, or the fact that the YouTube video stopped for? I've got no idea why that stopped. Okay, Elnaz is happy for me to go through the code next week. Sorry, next month. I'll do that. Okay, well, thanks for watching, and yeah, machine learning next week or two with Arun. Catch you later.